So we're looking at question number 3 from last year's exam, and we're looking at the intent of this question, being able to look at a normal distribution, perform some calculations, and look at some probability calculations as well. So if we go ahead and look at question part A, we're told that it's approximately normal with the mean. How many of you drew this, by the way? I drew it when I would have drawn it. So if you drew your normal curve, you can put your mean on here of 120. Did anybody go out 3 standard deviations above and 3 standard deviations below out of curiosity? If you did it, that's fine. You didn't have to, but that's just a good visual, so you can kind of see how big to get. What I mean simply is this: if you went out 3 and down 3, we know that 99 point. What's the empirical rule? 99.7% of the data falls between 3 standard deviations on either side of the mean. So I just simply mean that this would be 130.5. And so forth. We can continue to add and subtract, right? All right. It didn't ask for a z-score. Okay. Did anybody find the z-score? Anyone just do normal CDF without a drawing? Let's see how that is assessed. Okay, with the grading rubric. So we're going to go ahead and do normal CDF. We're trying to figure out, what is the question asking you? Probability of they're going to lose funding, so that they will lose some state funding, which means that more than 140. So if we're going to draw it, and we did 120, 140, and then you drew it and you shaded this way. Anyone do that? Okay. So you would just simply do 140, E99, 120 is the mean, and standard deviation of 10.5. What probability did you get the same that they did, 0.0287? Yep. Okay. And so that looks like what we should have got. That would have been okay. It did say probability, so probability is usually not given as a percent.
That's what I got.
Okay, and that is fine. Yes. I think if you did it this way, you got the exact answer. Theirs is off. Perfectly okay. Okay. All right, let's keep going. Maybe it's going to ask me to erase that. That's fine. We'll erase you. All right, let's look at part B. So what is part B asking? Part B is asking for us to be able to decide whether it's more likely or less likely, or equally likely, that we'll lose funding compared to this plan as opposed to in Part A. So what's the difference in plans?
One is over 1 day.
Okay, one is over 1 day, and one is over a period of 3 days. The answer should be that high school A would be less likely to lose state funding. With a random sample of 3 days, the distribution of the sample mean would have less variability than that of a single day. Okay? I'm not sure if they're going to ask you to say those exact words, but if you're looking at over a period of time, when you only take one little teeny sample, that's going to be highly variable as opposed to looking at a larger picture. Okay? With less variability, your standard deviation changes, doesn't it? 10.5 divided by the square root of 3, so we now have a new standard deviation here. Do you agree? Okay, it's the standard deviation of the sample means, right? And then we have, if we did a new z-score, you could have just done a normal probability calculation. And so instead of what we did before, it would be normal CDF, 140, E99, 120, but my new standard deviation would be 6.062. Did you guys do that differently? Did you do that? No? There's a lot of talk. What am I doing that's freaking y'all out? Hello? What did I do? Are we okay? Sure? All right.
So you just found
a new standard deviation. Yeah. So when the sample size is 3, I have a new standard deviation. And that's all. That's the only thing that's different. You find your new probability, and we got 0.0005, which is a lot smaller than 0.0287, right? So high school A is going to be less likely to lose the funding, right? We're more likely to lose the funding in Part B. No. Is high school A in part B, is that the problem? Is that why I'm getting confused? Okay. I hate when they do that. High school, why couldn't they just call it like, Woodrow Wilson High School or something rather than high school A? Whatever. Right. And I'm thinking that we're in question B, so that should, anyway. All right, so let's look at part C. I know, I just don't like it over here. It's mad. All right, so for part C, it's asking you to calculate a probability again, but in this case, we're talking about choosing one day at random from 3 school weeks. We're looking for what is the probability that none of the 3 days chosen is a Tuesday, Wednesday, or Thursday. So if it's the probability for any one typical school week is 2 out of 5, because it could have been Monday or Friday. So it's 2 out of the 5 days, right? So 2/5, and then it's just to the 3rd power. Or you could have done 2/5 times 2/5 times 2/5. That's probably what I would have done, slot diagram, and gotten 0.064. I thought this was a pretty straightforward question, personally. But it's all, do you remember all this stuff, right? Did you remember to divide by the square root of the sample size, that kind of thing? Let's see how it was scored. A, B, and C, so it's divided into 3 parts. And each part, A, B, and C, was graded as an EP or an I, essential, partial, or incorrect. So for part A, you had to have 3 different things in order to get an E. It says you indicated the use of a normal distribution and clearly identifies the correct parameter values. Showing z-score calculation is sufficient. Now, a question consistently has come up, is the calculators speak normal CDF, lower bound, upper bound, mean, standard deviation, enough to verify that? And they've gone back and forth with that. So let's look at the notes and let's make that decision. I didn't grade this question last year, so I'm not exactly sure. But if we're doing that calculation, shouldn't we probably say that it's normal with a mean and a standard deviation? Remember how we talked about identifying which distribution we're going to do? So that would have been good to do, okay? Drawing out your normal curve with the mean and the standard deviations up and below would have been okay too, I think. But I don't know if normal CDF with the I don't know that that's enough, quite honestly. But we'll look and see. Uses the correct boundary value, which we did. Reports the correct probability consistent, so just the right answer. So we're looking for, did you know that it was normal? We'll see if normal CDF is mentioned. I'm of the generation in the statistics world that thinks that that's enough information. You're showing it's normal, you're showing the boundaries, you're showing the mean and the standard deviation. I think that should be enough. But I don't know that I'm always right. How many of us, how many think you got an E on that one? 5 of us? I wish there were more. All right, it's partial if you just did 2 of the 3. Let's look at part B. So part B, we have to clearly reference the distribution of a sample mean. I don't know that all of us would have said that. Anyone in their write-up for part B say the word sample mean? Probably not, right? Anyone just find the new standard deviation and calculate the new thing? Probably what I would have done. So I wouldn't have gotten an E on this question either. They're looking for referencing that we're talking about a sample mean here. It also says you have to say that the variability is smaller and that it still has the same center. So what are we referencing? We're referencing shape, center, spread again, aren't we? Okay. Or you could have gotten an E by calculating the probability and comparing it to the part A. So if you correctly calculated the new standard deviation and found the new probability and then said it was smaller than that you found in A, you still would have gotten an E. Okay? So I probably would have done this to get my E. How about you guys? Tell me what you did. Did you do that? Did you find the new one and calculate its probability? You're looking at me like I have 5 heads. What's going on? Did you just not do that at all? Wake up, love. All right, and then for the last one, to get an E, we would have gotten just a correct calculation, quite frankly. Oh, I already did that, sorry. Didn't understand it. They wanted you to find a new Z-score in that one. Part 3, where's part 3? Do you guys see it? Part B, part C, there we go. Basically, work and the probability. That's all we're looking for part E. Okay. Did anybody get either a 3 or a 4 on this question? I was hoping that there would have been lots of 3 or 4s because I don't think this was too bad of a question. Is it, now that I've gone over it, it's easier, but when you looked at it, it was hard? That typically happens. All right, go ahead and put this away. I'll give a question. Or you just kind of, yeah, go ahead. You'd have to say 2/5 to the third power, or 2/5 times 2/5 times 2/5, without just an answer. That's enough answer. Yep. Perfect, that's fine. That's enough for me, enough for them too. All right, go ahead now, put this away for me, and we are going to kind of change our shift or our thought process for just a second, or not for a second, for the next kind of few class periods, not right this second, in a few minutes maybe, okay, and look at some questioning, okay? So, Evie, let's pause for a second. Let's do a shift. I want everybody to grab their stuff. You're going to find a new seat in the classroom. Different table, move seat. So this is going to be our seating arrangement for their while, okay? Like I said, that we are going to spend the next few weeks dividing up our entire AP Stats curriculum into 4 themes. If you haven't already gotten the Barron's Guide, it's not required. I am going to be giving you printouts of questions that we're going to be using. And I've numbered them on here, but I do believe, like, if you look at it, says page 13, number 1. That's for version 3. And I'm not sure what Barron's Guide version we're up to now, but I know it's not 3. I would say it's 5 or 6. So the questions are probably in there that are probably just not numbered that way. But I'll be giving these printouts to you for each of the 4 themes. Now, each theme is also divided into topics, okay? And we're going to kind of, the way I designed our curriculum is that I started from the beginning of the year, and we are going to go through the themes just as, so this is all the stuff we see here, stuff we did way back in the beginning of the year, okay? And we're just going to kind of review and go through and make sure we understand the questions. And we'll see some different types of questions because they are mostly going to be multiple choice, which means that we'll practice strategies on how to take and what we should eliminate and when do we answer and that kind of thing. Because the same rules apply for the AP exam as they do for the SAT exam with multiple choice questions. Leaving a question blank, in theory, will not hurt you. But you can't leave the whole test blank and answer one question and get a high score, okay? It doesn't work that way. But there is the way that it is calculated. All right, so if you have no idea, it's okay to leave a question blank. Okay? You should, if you have no idea. If you can eliminate one answer choice, you should answer it. It's the same. Same company. But we'll go through all the strategies as we get there. They have recently changed the way the multiple choice questions were graded. So I want to get those regulations up and tell you exactly. So I'll pull those. We're running out of time today. I'll pull them up and I'll add that to my list of the T-tables and how are they calculated. We'll pull those up and look at that on Friday to be for 100% sure. All right, so we're going to talk just for the rest of class today. I think we'll probably only get through topic 1, is graphical displays, okay? Now, I have tried to tell you several times throughout the year that AP loves dot plots. Okay, why do you think they love dot plots? It what? It shows a melody? Oh, normality, I'm sorry. Shows shape, right? Definitely. What else? Why a dot plot, not a histogram? Because you can count to find the median, right? You can actually count to find the middle score. So they don't often, but I have seen several instances of dot plots, okay? A bar chart is not a histogram. When is a bar chart used? Is a bar graph used? What kind of data are we talking about? Categorical data, okay? Histogram is when we're talking about quantitative or measurable data. Cumulative frequency plot, what's another name for that? It's my favorite word in statistics. Ogive. I love it, right? So ogive is a cumulative frequency plot. What kind of a shape should an ogive be in? Or will they always should be in? S-shaped? Good, John. Very good. Yep. And then we have stem plots. Okay? And often they will see a back-to-back stem plot because they compare two different distributions. So often with stem plots, they're back-to-back. Okay? When we talk about a graphical display, often it will be presented to you. I have never seen them ask you to create a graphical display. Okay? So you will not be making them yourself. What you will be doing is interpreting ones that are given to you. When we look at graphical displays, often they'll ask you to compare distributions or use information. What three things should we always be careful of? Shape, center, spread. Okay? So there's definitely something that you should write down and you should remember. But shape, center, and spread are the three big things that we're going to be looking at with graphical displays and comparing distributions. Center and center, what are some measures of center that are specific to our purpose? Median, mean, okay, those are typically the two that we use. Modality, bimodal, multimodal, unimodal, typically refer to shape as opposed to measure of center, right? 2 peaks versus 1 peak. So modality typically discusses a shape as opposed to a center. When do you use median versus mean? Do we remember any of that stuff? Skew versus non-skew. And so Jasmine, if it was skew, what should I use? Good job, the median. Do you remember this? If the median is larger than the mean, we should be able to tell, you should be able to decide the shape. Remember this, sort of? Well, let's go backwards. If they were equal, what do I know? Oh, let me be consistent. If the median is equal to the mean, what shape is it going to have? I can't hear you. Symmetric. We don't know if it's normal. I mean, we just know it's symmetric. It could look like, that's symmetric, isn't it? Okay, so if the mean and the median are equal, it is symmetric. Okay, what about if the median is bigger than the mean? And I guess maybe if you could look behind Kyle and Sean for our population graph, that might give you a clue, because in that case, I happen to think, I keep wanting to write mean first. When the median is less than the mean versus the median is bigger than the mean, I happen to think that that is the case for case 3. The population of NFL salaries, isn't the mean dragged out to the tail? So isn't the mean going to be larger than the median in that case? So what shape would this have? Skew right. So what would it be the other way? Skew left. Now we also want to discuss using words like approximately, right? We never say it is definitely, severely skewed, blah, 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 right? Unless heavily is a word we could use. How about the population of NFL salaries? Is that going to be a approximately skewed right or a heavily skewed right situation? Heavily, okay? It's definitely heavily skewed right. So we want to use these words, heavily, approximately, sort of. Don't use sort of. Sort of, kind of. But approximately is a good one to use. Okay? But being able to compare our measures of center to help us determine what the shape was. If a graph was not provided, okay, that would be a case. But we are going to look at just the types of graphs and displays. What do you think I mean by clusters and gaps? At what point would I discuss clusters and gaps? With the shape, the center, or the spread? Probably shape, okay? It's clustered around the center is sometimes what we usually say, or we could say for unimodal. There is a gap. A gap would indicate possible outliers. Would you agree? So clusters and gaps and outliers, for that matter, all are referring to a shape. Okay? Modality, we talked about bimodal, multimodal, unimodal, all deal with shape as well. All right, so let's go ahead and look at the first question. So you have it here. We have the first two questions actually are on your sheet on the bottom. I'm going to pause the recording and I want you guys to answer those. Now they should have A, B, C, D, E or whatever. I just rather just circle it. I think they're just dots as opposed to the letter. But go ahead and do that for me. Answer those first two questions. 19. And I agree. There's only 19 students. No big thing. Doesn't affect the shape. How would you find the shape? What'd you do?
I put it all in this one and did one bar stack and saw the mean and the median, and the median is larger than the mean, so I said it was skewed left.
All right, and that's perfect. Go ahead and find the mean and median of this and compare them. So that way we don't have a graphical display to use, but you're going to be using this information here to decide whether it's symmetric or skewed right. Yes? Okay, be wary of the histogram on the stat plot because it tends to create classes that are really large and sometimes don't show skew very well. You could, does it show up relatively well here? It does, okay. Sometimes it does and sometimes it doesn't. So I say to be wary of using that feature in this case. I kind of think that using the calculation that Hunter described might be quicker. What did you guys get for this though? Skewed. Skewed what direction? Left. So there's a few smaller scores, and more of the scores are higher. So I agree. Skewed left. Okay. So let's circle that one. B. All right. How about question 2? Let me give you a second to work on that one. This is one of those 1, 2, and 3 questions, which, by the way, they are getting away from, but we're still going to do them. So just go through and renumber them 1, 2, and 3, please. So this one is Roman numeral 3 only, so let's just go through them. Stem plots are useful for both quantitative and categorical data sets. Why is that not true? You don't use it for categorical at all. And not only that, but stem plots are easily useful for only what kind of data sets? Small ones. Large data sets are what's a good graphical display for those? Histogram. Because you can put them into bins, right? And you can create a graph based on that. Okay, so large data sets, histograms. Small data sets, dot plots, stem plots. And so really it's just going to be Roman numeral 3 only. Okay. Now we are kind of running out of time, so let me go ahead and assign to you the questions out of this theme that I'd like for you to finish. I do want you to get through, there's only one more question on topic 1, by the way, but I think I would like for you to get through topics 1, let's do through topic 4. Okay, so it's almost all of it. We'll save topic 5 because it's talking about categorical data, and so it's kind of its own little bird. So we'll talk about that together, but it's multiple choice questions. It shouldn't be too bad. So just do topics 2, 3, and 4. Okay, and then we'll go over those answers next class, and then we'll talk about topic 5 in class. So in this, for the topic 1 for your homework, I just want you to finish in theme 1. I want you to do topics 2, 3, and 4. Yes, yeah. I tried to give you enough room so you should be able to write right on here and show me any calculations or anything that you would need to go right on here as well. Let me just double check to make sure that there wasn't anything typographical that I need to tell you. Oh, there is. So, you guys need some information. Are you ready? So if you would find topic 2, page 40, number 3, you need a graph that goes with that, okay? Because it says to the corresponding histogram. Do you see that? So page 40, number 3 on topic 2. You need to graph this histogram. So if you would please do this for me. Making sure I'm doing this right. Okay, right. Well, that's supposed to be the 50. Sorry, y'all. Okay, so draw that histogram for me. And then you have to draw the box plot. So this is the histogram. It should be a 40, 10, 20. They go up by 10s. Okay, so there's a histogram. And then you had to figure out, how about for this one, just draw, not this one, we'll treat this as a non-multiple choice question. So in this question, I just want you to draw a box and whisker plot, or a box plot that matches it. I'll say that might, match this histogram. Okay, so we'll treat this as a non-multiple choice question, but just kind of sketch a box plot that would have that would correspond about the same data. What kind of shape would it have? Okay, so that's what I'm looking for that one. Let me just double check that there's nothing else. I don't believe so. I think that was the only one. Okay, so if you would, just make sure you have these done by Friday, and we'll finish up theme 1, look at a couple more FRQs, and we'll go from there.